Hello and welcome again to 2.15 Vertex Form. This should be review. I am going to change the notes up a little bit as we go. I'm going to reveal both red and blue for this. The method I would like to use is blue, but I want to cover all bases in case you choose to use the red Vertex Form formula. Okay, with that said, let's just dive right into it. If you do need to review this, you can always go back and check the Vertex Form lesson from Cycle 1. I think that was a pretty decent lesson after the Transformations lesson. Transformations was a little bit tricky, but I like the Vertex Form. The second one, whatever that was, I believe it was Vertex Form. Okay. For the vertex, if you're using the red method where it's x plus h in the brackets, it's going to be negative h and k. As long as you remember that whatever's in the brackets that sets it to 0 is going to be the x value of your vertex. So I'll put a little or h comma k, and that's if you use the blue. I like to use minus h in my formula because then I remember that I have to make it equals 0. So if you have minus 8, then x is equal to 8 for your vertex. Axis of symmetry is going to be x equals negative h, or in blue, x equals h. X equals, or y equals x squared is stretch or compress by a factor of a. So that doesn't change. Direction of opening, well, that depends on the a value. Up if a is positive, down if a is negative. Your zeros, you sub in 0 for y and isolate x. So to do that, you're basically going to expand and simplify and solve for x. The number of zeros, if you recall, 0 if a times k, so a value, the very first, times k is greater than 0. 1 if a times k is equal to 0. So if k is 0 or a is 0, well, if a is 0, then it's just a line. If k is 0, then you have 1, 0. And 2 if a times k is less than 0. So one of them has to be negative for you to have two zeros. Standard form to vertex form is by completing the square, and we're going to review that. If you don't remember, don't worry, we're going to review it. I had to review it again for this lesson because it's not a method that's used very widely after you're done dealing with quadratic relations, and I was able to get by factoring and then taking halfway between the two zeros. So that was the method that I used in high school, but I wouldn't recommend it because completing the square is so much faster. All right. First example. Find the minimum value of the parabola. For this, we need to complete the square, and in order to complete the square, you're going to take out a factor of the a value. So you're going to have y equals 5, because that's the a value, and you're just taking it out of the first two terms. So minus 8x, and then plus 70 at the end. Okay? Next, you're going to take that second term in the brackets, divide it by 2, and then square it. So negative 8 divided by 2 is 4. 4 squared is 16. And I'll show you what we'll do with that 16. Minus 8x. And that's going to be plus 16 minus 16 plus 70. Next, we have, well, we complete the square and we multiply the 16 out. So I'm just going to do a side over here, because 16 is going to multiply by 5, and that's going to give us negative 80. So negative 16 times 5 equals negative 80. Perfect. Okay. So then we have 5. We complete the square for the first 3 terms. So that's basically just factor what multiplies to 16, positive 16, but adds to negative 8. If you said negative 4 and negative 4, you are correct. So you get x minus 4 squared, because it'd be x minus 4 times x minus 4 in brackets. And what we did with that 4th term in the brackets, that negative 16, we take it out, multiply it by 5, and then add it to the end. So we're with plus 70 still. And then this is where that minus 80 comes in. So then you collect like terms, and we are left with minus 10 here. So then your minimum value should be minus 10. Perfect. Beautiful. If you don't remember completing the square, you can always go back to cycle 1 and rewatch that video and relearn that lesson. I would strongly, strongly recommend you have a thorough understanding of completing the square. You can get by without it, but it is a lot more work. So I still recommend doing it that way. Okay. Find the points of intersection of the parabola y equals negative 2 bracket x plus 3 and bracket squared plus 8 and the x-axis. So where are the zeros, basically? So we're looking for our zeros or x-intercepts. So where are these? Well, there is 2 methods. I strongly recommend method 1, and I'm going to reveal that. So we'll say this is method 1 to finding your x values. And you set it up y is equal to 0, and we're going to start isolating the x value. Now we're going to need to expand this eventually, but we're going to move the 8 over first. Then we're going to divide both sides by negative 2, so we'll end up with 4 on the left side is equal to this quadratic relation over here. Then we expand. Or actually, we don't expand in method 1. This is where it's different and where you actually save a lot of time. You take the square root of both sides, because when you take the square root of 4 and the square root of x plus 3 squared, that squared and that square root is going to cancel out. So what's the square root of 4? It's just plus minus 2. Positive and negative 2, because negative 2 squared gives you 4. So you have to be careful. It's going to be positive and negative 4 is equal to x plus 3. Then you can bring it down one more step. So really, if you brought 3 over, it'd be negative 3. So positive 2 minus 3 would have been negative 1. Negative 2 minus 3 would have been negative 5. I'll say that again. If you bring the 3 over to the left side, you have negative 3 plus or minus 2. So negative 3 plus 2 gives you 1. Negative 3 minus 2 gives you negative 5. And that's how you got both solutions here. Those are your x-intercepts. Okay. That's the first method. I strongly recommend it because it's going to save you a lot of time. It's a lot less steps. And it does play into what we're going to do later. And it's going to make your life a lot easier later. However, there is a second method, and I would feel guilty if I didn't include it. So this is method 2. And this might make more sense to you now if I go through method 2. So method 2, you set it up the same way. Plus 8, except you expand it. So now you have x squared plus 6x plus 9 plus 8. And you keep expanding it. You have to multiply the a value in and then add the there's that, and then add the 8 in at the end. Oops, that should be minus 12x minus 10. All right, then you take out a factor of negative 2, x squared plus 6 plus 5, plus 6x, don't forget your x. Then you factor. And if you factor, you get negative 2, x plus 1, x plus 5. Because 1 times 5 gives you 5, but 1 plus 5 gives you 6. So that's the other method, and I don't strongly recommend that, just because it is more steps, and method 1 is going to make a lot more sense to do, especially in later examples. I think in the next lesson, it's going to be a lot more straightforward as to why you would do that. Okay. And I'm going to be sticking with method 1 from here on out. So your points of intersection are -1, 0, and -5, 0, because your x values have to go in for the x values of the points. Okay. Next slide. Find the equation of the parabola shown. Well, we're given a few points. We're given the vertex to start, and then we're also given this point 1 or -1, +3, and we're given the vertex, which is -4, -3. So we can actually use our vertex -4, -3. And we can set up our vertex form, which should be y equals a bracket x plus 4, because it has to be the opposite sign of that, plus 4 n bracket squared minus 3. Perfect. So now, once you're at this point, you need another point on the parabola, which luckily we have, to sub in. So in this case, we have this point here. So now we're going to sub it in for the x and y values. We have 3 equals a, so now we're actually going to solve. -1 plus 4 is going to give us +3. 3 squared is going to give us 9, so we'll have 9a minus 3 is equal to 3. If you move the -3 over, you'll get 6 over here, so you'll have 6 is equal to 9a. Divide both sides by 9. You should get 2 over 3 is equal to a. And therefore, now we sub the a value back into our equation back up here, so we'll have y equals 2 over 3 bracket x plus 4 n bracket squared minus 3. All right. Very quick example. That's pretty straightforward stuff. You guys have been doing this for a while now, so I would expect you to be able to do that. Let's move on to the next example in 3, 2, 1. Okay. Example 4. A soccer ball is thrown from the height of 2 meters and reaches a maximum height of 3.6 meters after 2 seconds. When does the ball hit the ground? Okay. Well, we're given a maximum, which means we're going to have a vertex. And we know it's this high after this many seconds. So we're given a point, the vertex point, of 2 seconds and 3.6 meters high. We're given a y-intercept. So that's going to be our y-intercept here. Okay. So that means that it's going to be, the other point is going to be 0 for x and then 2 for y. Okay. Well, we saw in the last example, if we're given the vertex and another point, we can solve for a and work our way backwards. But here we're trying to figure out when does the ball hit the ground. So it's going to be a combination of the last 2 questions. And this is why method 1 is going to be so much nicer. Okay, let's get started. First, we're going to start with our vertex form. Y is going to equal a times x minus 2, because it's got to be the opposite sign of the x value of the vertex right here. And then n bracket squared plus 3.6. Perfect, exactly what I said. Now, we're going to sub in the y-intercept, which is 0, 2. So we're going to sub in 0 for x and 2 for y. And now we just solve for a. So negative 2 squared, that's going to be 4a. Bring the 3.6 over. We'll get negative 1.6 on the left side. Perfect. Whoa! Negative 1.6 is equal to 4a. Divide both sides by 4. You get negative 0.4 is equal to a. Now we have this a value. We have to work through this like we did 2 examples ago. So we set up our vertex form first, and we set it equal to 0 instead of to y, because we want to find the zeros, or the x-intercepts. So that means that this has to be 0 here for our y value. Okay, so what we're going to do is we're going to work through this like we did before. We're going to move the 3.6 over. Then we're going to divide both sides by negative 0.4. And now we're left with 9 is equal to this square here. These are both square numbers, so we can take the square root of them. If we take the square root of this, we should get plus minus 3 is equal to x minus 2. Okay, this is where that last step comes in. Negative 2 goes over, becomes positive 2. So positive 2 plus 3 and positive 2 minus 3 will be our two zeros. So at x equal to 5, or x equal to negative 1, well, which one of these makes more sense? If you said x equals 5, then you're correct, because we can't go back in time, so it has to be 5 seconds. That's why we had to choose the 5. All right, so clearly we see that it's a combination of the last 2 examples. If you're having trouble with it, try drawing it out. You could have drawn a diagram. It will look something like this, and it doesn't have to be perfect. You would have known the y-intercept here is 0, 2, and it doesn't have to be super accurate. And you know your vertex up here would have been 2, 3.6. And then you had to figure out what was over here for your intercept. And then maybe that would have made a bit more sense. When in doubt, you could try drawing something, trying to see if that will help you figure it out. If it doesn't, I would suggest looking back at your notes while you're going through your practice. Okay, if you have any more questions, make sure you post them on the forum, and best of luck.